Hello, my name is Israel, and today I'm going to be explaining my Java project on inheritance and polymorphism using a car example. My project has a drivable interface, a parent class called car, the two child assets, electric car and gas car, and the main demonstration class called car demo. Right now on screen is the drivable interface, and I made a quick comment saying that how it defines two methods that every vehicle must implement. So every child asset is gonna utilize these methods on their own classes. In them I have two methods. I did the first one, which is double, and it's calculate trip cost. This one is going to calculate the cost of the trip based on the user input, and then returns the calculated trip cost. On the second method, I have modify speed, which modifies the speed of the vehicle based on the user input. Now, on the parent class called car, um, I decided to utilize different attributes for the car. So I have the model, which is a string. Then I have the fuel efficiency, which is a double, and then I also have a current speed, which is the end. And then as you can see, I have the uh, the methods from the other interface class that we had over there, or not class, the interface. You can see the getter and setter methods for all the attributes I just mentioned. Now I made a quick example here. So for this one, or not example, comment, sorry, for the what I'm seeing right here. So the calculated trip cost, I'm gonna ask the user to input a trip distance, and then I'm using the default price of $3, which can be tweaked in the program. It's gonna give them a calculated trip cost. This is also the same with the speed. So they're gonna type in the speed, and then it's going to update the object state, and then it's going to return a string representation with the car's attribute and a string representing the car. For the electric car, same thing. I have it so this is a child class for the car class, and the unique attributes for this one is the battery capacity, because since it's an electric car, it runs differently than a gas car, of course. So I added that on there. Over here is the same thing, but there's a difference because since it's an electric car, it has a different it doesn't use gas, so it doesn't have mile per hour. It has kilowatts per hour. So I have I tweaked it so that it's 12 cents per kilowatts. Um, then the user would input their distance, and then it will return a calculated trip cost. Same with the speed. It will do that, but this one is a little bit different. I made it so that it will simulate the battery's usage by reducing the battery capacity when the speeds increases, because that's how electric cars work. Their range drops as you keep increasing the speed, rather than a gas where it depends, or it follows that mile per hour method of uh, seeing how much gas it can take based on speed, or consume, sorry. And then I have the gas car class, which is also a child class for car, for the parent class car. I typed in over here, the gas car class represents a gasoline powered car. I did that even though it's kind of obvious, but I did it just because I was using the electric car class on the other side. Um, but it's the same. It's gonna utilize the same attributes as mentioned before. But this one, it's gonna utilize a unique one, which is the tank size. So the tank size is very unique because, of course, like I mentioned before, on the electric car depends on the range, on the battery, the range of the battery, and the gas car depends on the range of the fuel tank. So I have the getter setter methods for the tank size, and then I have the calculated trip attribute that I utilize that set in place by default on all the classes. For this child class, I have it so that the uses a gas price, like a default price of 350 per gallon. And then it's going to prompt the user to input the trip distance, and then I'm going to return a calculated trip cost based on that default setting that I put for the gas per gallon price. Um, and then on the bottom, I put in the modified current speed based on the user input. And additionally, I put in that it warns about potential fuel consumption if speeding up. It's the same thing I did with the range, battery range on the electric car. It's gonna deplete or give you an updated version of the like an updated number based on how fast the speed of the user input put in. For example, if they put in a speed that's high, it's gonna let them know that the consumption is gonna be a little bit higher, as you can see here. So I put an if so that you see how it's like printing out may consume more fuel at high speeds. This is all depending on how the user inputs or what type of speed or how fast they're going. And then finally the car demonstration. I created basically creates an array of car objects that holds both electric car and car instances. And then it displays the initial car info. And then for each car, it prompts the user the trip distance to calculate the cost. Prompts the new speed to update the car state as well. I do want to point out that it demonstrates the polymorphism. Even though we use car array, the override methods in electric car or gas car are called based on the actual object. And that's pretty much it. I'm gonna run it real quick so I can show the output of it. Okay, so see now it's gonna ask me an input on every car. So if I type in a trip distance of 53 miles, it's gonna tell me that it's gonna be 742. This is all based on the default settings of 350 that I put it on for the gas car child class. And then it's gonna ask me for the speed, and let's say I'm gonna go 45, and it updated the default the data that it was already in place on top with the data that the user is inputting. And you can see how it says now it's 25 miles per unit as the fuel efficiency, and then the current speed 45 that he just typed in, and then the tank size for the speed that he's utilizing. Or the tank size is a tank size based on the every single car. So every single car has a different tank size, and then electric cars have battery capacity that is different from one another. Tesla model. Let's say I'm gonna go 30 miles. Then it's gonna tell me it's 90 cents. This is all based on the kilowatt price that I set in place for 12 cents. And then the speed, let's say I'm gonna go 35. And now it updated, so it's 98.25 kilowatts. That's the battery capacity that it currently has, like I mentioned on top on the child class. The other car that I have in place is a gas car. It's pretty much the same process. So I'm gonna kind of speed through it. And that's gonna be all for my project. Thank you for watching.